everybody, it's Jason again, here to tell you about another fun activity that concerns our little pals, the bugs. Now, there's so many things that we can learn about bugs, but we only have a couple activities to do it in. And one thing that's really fascinating about bugs are their eyes. Bugs can have really simple eyes, like we do, or they can have compound eyes, where they see multiple images at once and then have to put it together in their little bug brains. So what we're going to do today is talk more about the colors that insects see, because it's really difficult for us to demonstrate to a student a simple eye versus a compound eye. We could do it with mirrors and whatnot, but it would take just a few moments. There wouldn't be much to it. So we decided to focus instead on colors. Your students are going to make a little pinwheel like this. This pinwheel has three different colors. It has a red, has a blue, and it has a yellow. That's because some insects are attracted to some colors, and some insects are repelled by some colors. Red is not an attractive color to most insects, but there is a particular insect that we all love dearly that's attracted to red. That would be the mosquito. Now, I know most of us really don't love mosquitoes dearly. They're a nuisance. They make our skin itch. They suck on our blood. But just like everything else on this planet, insects and otherwise, mosquitoes have a purpose. So even though they're kind of bothersome to us, we don't want to get rid of them completely. And so we study them to understand them better. And we learned through study that they're attracted to the color red. Now, some of you may be thinking they're attracted to the color red because blood is red. It's not the reason at all. We're still kind of trying to figure out what it is about red that they like, but it has nothing to do with blood because they also like really dark blue, just the colors they're attracted to. Now, other insects like bees, they don't see red at all. They can't even see that color. So they don't care about red. If you're wearing a red shirt, they don't even see it. They're just kind of spinning around you, past you, without even knowing that you're wearing a red shirt. But bees and butterflies like colors like blue and yellow. That's because pollinating flowers tend to be blue and yellow, and then they go there and pollinate the flower. Now let me tell you right now, I will digress for a moment to give you a little bit of a public service announcement about our friend the bee. I know many of us don't like bees. They sting us, they kind of buzz around our head, they're kind of a nuisance. But I'm going to tell you this right now, and I want you to tell your students this so they understand. Bees are one of the most important animals on this planet. If bees were to go extinct, most other life on this planet, other than probably bacteria and very hardy insects like the cockroach, would go with them. They pollinate flowers that allow other things to germinate and grow. And bees are one of the primary pollinators, along with butterflies, on this planet. So when a bee's spinning around your head and you feel that need to slap it, don't do it. It's only spinning around your head because you smell nice. I'm not even kidding there. Whatever perfume you're wearing, cologne you're wearing, deodorant you're wearing, it's attracted to the bee, just like the flowers are. And they're just kind of figuring out, what is that smell? It smells nice. I'm going to be around this person. So just leave it be, because we want bees to live a long happy life so that we can continue living long happy lives. Just need to tell you that. It's a good thing to tell your students so that they can understand why bees are important. So, like I'm saying to you, bees and butterflies really like these blues and yellow colors. But bees can also see something that we can't even see. If you take the red and the blue filter and put it together, you get sort of a purplish color. That purple color is not what they see. But when you put this purplish color up to your eye, you're kind of seeing what a bee sees, which is what we call ultraviolet. Ultraviolet's a very important part of the electromagnetic spectrum that human beings can't detect, but bees can. And why this is important is a lot of those pollinating flowers that bees are attracted to leave signatures in ultraviolet to let bees know come to me and pollinate. Very, very important stuff. So when you're making your pinwheel, make sure that the kids can go ahead and put it together, the red and blue, so they can see that ultraviolet. In a few moments, I'll tell you more about the electromagnetic spectrum so you can understand it a bit better when they're asking questions about it. You can also put blue and yellow together and get sort of a greenish color. It doesn't work that well, but butterflies are also very much attracted to green, so you can demonstrate that. So every student is going to make one of these, and it's not that hard to make. It just takes a little bit of time. Since I already made one, you can sort of see how it looks. I'm not going to make another one because it's just going to take me 35, 40 minutes to make, and you don't want to sit here and watch someone making one of these for 35 to 40 minutes. But I'll give you an idea of how to make it. First of all, you're going to go ahead and pass these out to small groups of 4, 5, or 6, whatever you want to do. Each student's going to be able to cut out 3 of these little sections, these little eyepieces. I call them monocles because it's a single eyepiece. They're going to cut it out so it looks like that. Simple enough. They then need to cut out the middle part so that it looks like this. There's an opening. All right? To cut out the middle part, you can either fold it and cut through the middle, or you can even cut a corner, cut out that part, and then tape the corner back up. It's up to you. It's up to the student how they want to do it. So they're going to do 3 of those, and then they're going to cut out a stick. Sticks look like this. They're going to cut out 1 stick. And then this is where a little bit of the engineering comes in. You're going to poke a hole to the corner of each of your little monocle pieces with this straightened out paper clip. Go ahead and just poke a hole through this corner. And line them up so you can poke them all at the same place. And then you're going to take these different cellophanes. Your yellow cellophane, your blue cellophane, and your red cellophane. And you're going to line up the eyepiece to the cellophane, and you're going to cut around it. And then you just got to tape it down. And you can do that with all 3 of them, and you have 3 little eyepieces. Then you're going to line up all the corners that you poked a hole in, and you're going to go ahead and put a brad through them all. And then you're going to poke a hole inside your stick. Poke a hole, and you're going to stick it through. And then you'll have something that looks like this. And because it's on a brad, they'll be able to move and shift. So you can move them around, and they can look at the one they want to look at. All right? If you guys have extra supplies, not all kids showed up that day. Usually you have 30 kids, only 20 showed up. They can make 2, 1 for each eye if they want. It's no big deal. Just make sure that every kid gets to make at least 1 before you do that. Again, this is an engineering project, so we want to help them, but we want them to be able to do it on their own. So you can give them suggestions, you can give them ideas of how to do it quicker, faster, easier, but let them do the work. Now, obviously, some of you have little kids, 3, 4, 5-year-olds. You might have to make a monocle for the whole group and let them all look at it together, like 1 by 1, or whatever you want to do. But don't just have one ready, make one in front of them so they can see the process, and therefore later on, they can remember it someday and make one themselves. Now let me talk a little bit about the electromagnetic spectrum I spoke of earlier. It's important because when you use that word ultraviolet, if you don't have a context for it, the kids are going to be confused. They're not going to understand what you mean by ultraviolet. So let me talk about this electromagnetic spectrum, a spectrum of radiations. There are some radiations that move very slow and have very long wavelengths. And as you move down the spectrum, the wavelengths get shorter and the energy becomes quicker. The very longest wavelength and the slowest moving one is radio waves. So kids can understand radio waves pretty easy. They listen to a radio. They understand it's a sound wave. After radio waves, you have microwave. That's something the kids can understand too. There's a microwave in their house. It's able to cook food from the inside out. They can understand that a little bit. We don't really see in microwave, but we know the effects. And we can see in microwave using telescopes out in space. They can take pictures of microwaves so that we can see what stars look like when they're emitting microwave energy. It's pretty cool. After microwave is infrared. Now, infrared is something that we can engineer to be able to see. Those are heat signatures. One thing that you can do to see infrared is there are these little black pads you can buy, and you put your hand on it, and it registers your heat. When you take your hand off, it shows which are the colder and warmer parts of your hand in different colors. One way the kids might really know infrared is if they have seen the movie Predator. I have to mention movies because kids watch movies, and they can understand their world through movies. That's what the Predator sees in it. It sees in infrared. So that's one thing you can actually tell them about. It's like, hey, have you ever seen this movie? That's what the Predator's looking at, infrared. And we don't see in that either unless we engineer a way for us to see in that. The next wavelength is visible light. That's the wavelength we see in. You may have heard of something called Roy G. Biv. Roy G. Biv is the color of the rainbows from least energetic wavelength to most energetic wavelength. Roy, R is red, O is orange, Y is yellow. G, green. Biv, B is blue, I is indigo, V is violet. Violet is the last wavelength of the visible light spectrum. It's the last wavelength we can see in. Right after visible light, right after violet, is what we call ultraviolet. This is not a wavelength we can see in. But as I said before, bees can. Now, ultraviolet is around us all the time. The sun shines down on us, UV rays hit us, that's what causes us to get sunburns. That's why even on a cloudy day, you need to go ahead and put sunscreen on because you can still get burned if you're going to be out in the sun all day. Again, ultraviolet, UV. It all ties together, and it's very obvious we don't see ultraviolet because it's always around us. Bees do, though. After ultraviolet, you have X-rays. Now, that is something we do see. We have seen X-rays before. You sit in the X-ray machine, you can see the bones underneath your skin. But it's dangerous. It's a highly energetic wavelength. That's why they put the lead padding over you, and they take their X-ray really quick, and they don't keep you in the machine long, and they're learning new ways to image us without having to use X-rays. And the final wavelength is gamma rays. And gamma rays are dangerous. They're very, very quick-moving, short-length wavelengths that are highly radioactive. You want to give kids an idea of gamma rays? Incredible Hulk. Bruce Banner was messing around with gamma rays and became the Incredible Hulk. This creature that can't even be controlled because of these gamma rays. So these little ideas that you can put in their heads, like, oh, the Incredible Hulk had gamma rays. Oh, the Predator looks in infrared. Things like that helps them to remember it because they like those pop culture references, and it's kind of fun for them. They're like, oh, that's really cool. The Predator sees that. And Bruce Wayne is, gamma rays, and then all this science is included in it. It's pretty neat. So you really, really, really want them to understand the electromagnetic spectrum so they understand what you mean by ultraviolet and when you say bees can see in ultraviolet. Now, studying the different anatomy or anatomical pieces of insects and different animals is a really important thing because the more we learn about the way insects see or the way spiders spin webs or the way dragonflies fly, we take these things that happen in nature and we learn to engineer them into something new. We learn that bees can see in ultraviolet, and we build devices that allow us to see in ultraviolet. Again, we can't see it on the regular, but we can build a device that allows us to see it. So by understanding how bees see, we can make devices to help us see what they see. Spiderwebs is a really, really good example of taking something in nature and using it for engineering purposes. The tensile strength of spiderwebs is enormous. They are very strong. They don't break very easily. So we look at that stuff and we think about this. Let's say someone loses all the ligaments in their knees. What if we use something like spiderwebs to rebuild those ligaments so that knee is perfectly new? Things like that get kids excited. Things like that help kids look at this science that we give them at ages 7, 8, 9, 10, and use it later on in a career. Okay, so this is our bug unit. This is our final lesson for the bug unit. Have fun making this. Again, let the kids build it themselves. Let them take their time. Let them enjoy it. And then let them experience the way a bug sees. This is Jason signing off one more time. Thanks a lot, everybody. See you next time.